Okay, in this video we are going to look at finding the equation given a graph. Okay, so we're kind of working backwards here. We're not given an equation and then looking to potentially graph it. Instead, we're given a graph. So here's an example. So given this graph, let's suppose we're looking to write the equation in this standard form. So make sure on your paper you just sketch and jot down those key points. So we need to think about which form that we can use initially to write this equation. Now, we're not going to be able to jump into this standard form of the quadratic. We're either going to use vertex form or factored form initially. And once you have one of those two forms, you can do some algebra to then turn it into the desired form that we need in the end. Well, because we know the two roots, it makes sense to use the factored form for a quadratic. So that looks like this. This is the general template for it. So you're going to have y equals, we're going to keep that a there for now. So if we know that our roots are -2 and +4, that means we're going to have x plus 2 and x minus 4 when we work backwards and get our factors. Right, so mentally just think about how if you were to set each of those factors equal to 0 and solve, you'd get roots of -2 and +4. Well, the last thing we need here is this a value. So that's where this other point is going to come into play. Keep in mind that with this other point, we really have an x and a y value. So what we're going to do now is we're going to use this equation. We're going to plug in 0 for x and -16 for y, and we're going to use it to solve for a. So let's do that substitution. So after doing that substitution, we just do the algebra. Okay, keep in mind this is a product all the way through. So -16 is equal to -8a. And when we divide that -8 over, we're going to end up getting a equals +2. Okay, so now let's resubstitute. So we know a is 2. Okay, so we're going to drop in everything else the way it was. Okay, so if it just said find an equation for this graph, we could stop here at that part right there. But because it wants it in standard form, we need to do some algebra. So we're going to first do our FOIL on the x plus 2 times the x minus 4. That's going to give us x squared minus 2x and then a -8. And then from there, our final answer, after we distribute our 2, would be this trinomial. Okay, that again now fits this mold of ax squared plus bx plus c. Alright, in our last example here, we have a quadratic drawn for us where we see -3, 4 is the vertex, and this point, -1, -2, is just a random point on that graph. In the end, we are looking to express this in this standard form. So again, we can't just jump right to that standard form. Instead, we're going to go first to vertex form and then do some algebra at the end. So here is what we said was the general template for our vertex form. We know the vertex is -3, 4, so that has really given us our h and our k. So we have y equals a. Now if I see -3 for the x coordinate of my vertex, I want x plus 3 on the inside there. And then I have plus 4. So remember, if we were working backwards, we would have changed the sign of what we see inside here to find that part of the vertex, and this plus 4 on the end stays as is. So now we need to figure out what our a is. So to do that, just like before, we're going to use this additional point as an x and a y. We're then going to be able to solve for a. So if we substitute in, we'll go over here. We would have -2, that's the y value, equals a times the x value is -1 plus 3 quantity squared plus 4. So now when we clean this up, remember we have to do this part first. So that's going to give us 2 squared, which is 4. Now don't forget that this is really multiplication, so you have 4 times a, and then you add on that 4. So I'm going to subtract over 4 now, so I'm going to get negative 6 is equal to 4a. A is equal to negative 6 over 4, which will simplify as negative 3 halves. Okay, so we're not going to panic that our a value is not a nice integer for us. Okay, it's going to happen sometimes. So our y equation, we have y equals negative 3 halves times x plus 3 quantity squared plus 4. Now we could stop there if they told us that we wanted our final answer in vertex form. But again, we are told we want it in standard form. So we have to clean this up a little bit. Okay, and it can be a bit tedious, but you know enough math to be able to do this. So first we need to do our FOIL there, right? Order of operations. We have to do a exponent before we can do multiplication by that negative 3 halves in front. So we would have y equals negative 3 halves, and then if I do my FOIL here, x squared plus 6x plus 9, we know we're going to get that. I'm going to carry over that plus 4. Okay, so now from here, let's distribute our negative 3 halves through these 3 terms. So if we do that, we have negative 3 halves x squared. Now negative 3 halves times that 6x, that's negative 18 over 2, which is negative 9x, right? And then that negative 3 halves times 9, that's negative 27 over 2. And then don't forget we still have that plus 4 hanging out on the end there. Well, there's one more move we can make, and that is to simplify those 2 terms on the end. So we're almost done. My final simplified quadratic term is negative 3 halves x squared. My linear term is minus 9x. And if I treat this 4 as really 8 over 2 to get a common denominator, I would get negative 19 over 2. Now, instead of writing negative 19 over 2, if you want to write negative 9.5, that's fine. Okay, but at the end of the day, we have expressed this in standard form. Okay, keep in mind that half of this course is no calculator. So sometimes you will see some messy examples like this where you are expected to do some work by hand. Okay, so you know enough math to be able to do it. So have the confidence, don't fear it, you'll be okay.